All right, I apologize that the big P keeps popping up. So here's the second half. I think it was trying to let you know you can write angle bisector as angle 1 is congruent to angle 2. Or we can say the measure of angle 1 equals the measure of angle 2. All right, it's important that parts can be congruent to other parts, but measures are equal to other measures. All right, linear pair postulate. So linear pair was already a vocabulary word that you had done, but there's a postulate that defines the rule. And I apologize for all the papers moving. Okay. If two angles form a linear pair, they will be and always be supplementary. And of course, supplementary, that's when you have two angles that add to equal 180. So in the picture, we've got an 80-degree angle, 100-degree angle, and notice they're sitting together along a straight line. They have that shared side, and so those will always add up to be 180. Now please add, this should be 80 degrees, 100 degrees, and 180 degrees. Vertical angles, those were the opposite angles, but there's also a rule that goes with that. Vertical angles will always be congruent. So if two angles are vertical angles, they are congruent, and you can see in the picture, all right, that these opposite angles are both 40, and that these opposite angles are both 140. And that has to be because the adjacent ones are a linear pair. And so if we use the rule above, obviously 40 plus 140, those have to add up to be 180. Okay. The next page are some problems that we can look at that you'll be asked to solve. All right. So in the first one, we're asked to solve, find the measures of angles 1, 2, and 3. So just to get ourselves set up, I'm going to find the measure of angle 1, measure of angle 2, and the measure of angle 3. So to find angle 1, the one angle we're given is 67 degrees. Angle 1 forms a linear pair with that one. So the math I'm going to do, and I'm just going to show it over here, is simply 180 minus 67, and we get 113. Make sure you put the degree sign because it's 113 degrees. All right, to find angle 2, well, I can simply use the vertical angle theorem, which says that vertical angles are congruent. So angle 2 must also be 67 degrees. And then angle 3 is vertical to angle 1. And since that was 113, angle 3 will be 113. Now the next two examples, throw some algebra in there. First thing you want to do is you want to identify the relationship. And what I mean by that is you're going to ask yourself, are these vertical angles or are they a linear pair? Now, you don't need to write down those words, but that's what you should be thinking in your head. And this relationship, because they are opposite, these are vertical. Vertical angles mean that they are congruent. And of course, congruent means equal measure. So that's how you would set up your equation. We're going to say 3x would equal 2x plus 16. Once you get your equation set up, you go side to side. So we're going to subtract 2x, and we're going to end up with 1x equals 16. Okay. The second algebra problem. Again, the first thing you want to do, you don't need to write it, but these are our notes. You're going to ask yourself, are these vertical or are they a linear pair? Since these are adjacent to one another, these are a linear pair. Linear pairs add to be 180. They are supplementary. So that's how we set up our equation. We're going to have 15t plus 20t plus 5 will equal 180. Now notice in the equations, I'm not putting the degree signs. All right, you don't want to do that in the actual equations. But when you're writing final answers of measures that represent angles, we need the degree sign in the answer. All right, combine your like terms here. So we've got 35t plus 5 equals 180. And then subtract 5. So 35t will equal 175. And then lastly, divide by 35. And final answer, t will be 5. Okay, all right. You can move on now to the classwork. Thanks for your patience.